Dear teachers and students, today is our second English medium seminar. I would like to welcome Mrs. Sachini De Silva, the teacher of Gonsalves School, who is conducting the seminar today. And I would like to welcome all the teachers and students. And we will live stream this session via Nigambu Education Zone official YouTube channel. And we will give you the link in the chat box. And thank you. And dear teacher, now you can conduct the seminar.
Okay, thank you, madam. Good morning, my dear children. I welcome you all for the science seminar, second session. Thank you, madam, for conducting these seminars. I think they are really helpful. I observed the last session also, so children participated actively, and I hope this will help them to refresh their knowledge and what they learned through this 2 years. Okay, but so today I'm going to do grade 10 third term lessons. I'm going to revise you like this paper. I think now you all have gone through the paper. Today I'm hoping to do like the 40 MCQs. If you had enough time, we will go for the theory paper as well. So in this session, I'm going to revise with you the last 5 lessons, because they are the lessons you are getting for grade 10 third term. Before this, I want to tell you, I don't want to give you the answers only. So I'm hoping to revise the things like the theories around each question. So before we start the seminar, I like if you all can get your short note or any small book to note down the things, because not just listening, it's easy if you note down things, because that you can use it as a short note. And if you are studying your textbook or your school book or class book, any book that you study, you can get ready with that thing. So until I give the brief explanation, it's time for you to get ready with your books, so you can note down the special points that you have to study, or maybe that you want to note down. Okay, so children, can you hear me well?
Yes, teacher.
Okay, thank you. All right, so then this one, we are learning for the second term. We have 5 lessons, like we have 3 physics lessons. The pressure lesson, in that you are learning about solid pressure, liquid pressure, and atmospheric pressure. And for the work power lesson, that is also physics, you are learning what is work, and you are learning power, about energy in that lesson, and there are some equations. And the other one is current electricity lesson. In that you are learning about static electricity and direct current, this how the current is flowing, and about resistance and the factors affecting for that. Those 3 lessons you have grade 10 third term physics lessons. And for chemistry you have 2 lessons. One is changes in matter, that is a little bit lengthy lesson, and frequent questions would be there from that lesson. And the other one is rate of reaction lesson. That is a small lesson, but still you will get some questions from that too. And the only one biology lesson is there, that is inheritance. So we have more chance to get questions from inheritance lesson, because that's the only biology lesson in the third term. All right, so I think you got a brief idea on what are the lessons we are going to follow. So in this papers, I have included all the questions from like to cover up all the lessons. And you can correct your answers while note down the important things. So my main task is not to get not just to get the correct answer, to have the theory around that. So that I think it will support for your O levels, and I think you have very little time now. Chuti kalaya koglante tiyenne, so you can get, I hope you will get the maximum that you can. Okay. All right, children. So we will start. Okay, so I hope now you all are ready with your learning materials. Like not only this paper, I want you to have your studying thing, that may be your textbook, your school writing book, or your class book, short note, anything. If I'm too speed, please let me know in your chat. And also, if you want to ask any question, you can ask. So I will just randomly check the chat and help you if you want to ask anything, or if you want me to further explain anything, you can ask from me. Okay, Pite, we'll start now. First question, which factor does not involve for the pressure of a liquid at a certain point? So when you give such questions within now the word this does not is bold in that. So you can underline that word because that is the important one, which is does not involve in liquid pressure. So here you have the equation. This is the equation you use for liquid pressure. P equals H rho G. Now, if anyone can't remember this equation, in your short note one, you can quickly write down the equation. P equals H rho G. So P means pressure, liquid pressure. It is measured by Pascal. And H means height, and always height or the depth of the water column. It should be given in meters. Rho means density, its unit is kilograms per cubic meters, and G means gravitational field strength, unit ms minus 2. Value of G is 10, you know that. If not, they will give in the question also. All right, so this is the equation. So when you see the equation, you can see the factors affecting. So height or the depth is affecting, density is affecting, gravitational acceleration is affecting. So what is a factor which does not affect the liquid pressure is volume of the liquid. So it is not affecting the pressure. So that should be the answer. So the thing I want you to get from this lesson is the equation. That's the important thing. P equals H rho G. In further questions also, you have to use this equation. So you have to by heart this. And also, if you talk about liquid pressure, there are some special properties of liquid pressure, like liquid pressure acts in every direction. So this diagram shows you that liquid pressure acts in every direction. And this one shows you that liquid pressure increases with the depth. This diagram shows you liquid pressure increases with the depth. One second. Okay, sorry. All right. So then liquid pressure acts in every direction. Liquid pressure increases with the depth, and the pressure at the same level is same. So these are the things you have to know about liquid pressure. All right. Then we'll go for the second question. Second question is, what is the SI unit of pressure? What is the SI unit of pressure? So for pressure, now we have two types of pressure, like solid pressure and liquid pressure. For solid pressure, we have this equation, solid pressure equal force over area. So if anyone want to know the equation for solid pressure, you can have that. Solid pressure equals force over area. So the unit of force is newtons. Area unit is squared meters. So you can take the equation for pressure as newtons per square meter, Nm minus 2. So that is the equation for solid pressure, Nm minus 2. We also can take Pascal there, but both are fine. Liquid pressure, you can use only Pascal. Solid pressure, you can use both the equations. So this is the equation for solid pressure, Nm minus 2. So your answer would be the third one. If you want to note down the equation, you can write solid pressure. And for solid pressure, there are two factors affecting. One is force, and the other one is surface area, where the force acts. So in this equation, you also can see if the force increases, pressure also increases. That means it's like directly proportional. When the force increases, pressure increases. And if area increases, the pressure would decrease. You know, in general incidents, like when you use heels in the shoes, when the surface area is low, the pressure would be high. And that's why the iron nails, we have like thin area at the bottom. So then they can give you more pressure because the surface area is less. And also the force, like now, think about large vehicles, they have broad tires. So then they make it more surface area. So to reduce pressure, otherwise because of the weight, they will give the road more pressure. So I hope you're okay with that pressure concept. So that is for the solid pressure. So the answer is Nm minus 2, third answer. I will go for the next question. Okay, next question. Now there's a question that you have to solve. Okay. What is the pressure exerted by water at a point located 2 meters vertically below the water level in a lake? So they have given density of water is 1000 and the acceleration due to gravity is 10. That values usually they are giving. So now it's for you the time to use the equation P equals H rho G. That's multiplication symbol. Then, so the height is 2 meters, or the depth is 2 meters, and the density is 1000. Acceleration would be 10. So if you, when you multiply all the three answers, you are getting 20 newtons per square meter. So the answer would be fourth one. Fourth one is the answer. Answer is 20 newtons per square meter. So I hope you could manage such a question. Most of the time in the paper, there will be a question from the liquid pressure. You just have to multiply the three answers. Unit, you can use either Pascal or newtons per square meter. Both are fine for the liquid pressure. All right, I will go for the next question. Fourth one. Okay. A swan of a swan of mass 1.3 kilograms is still at water. What is the upthrust acting on the swan? Okay, so then with the upthrust. Upthrust means the upward force given by an object when it is fully or partially submerged in a fluid. So when they call fluid, it may be either gas or liquid, but mostly we are talking about liquid. So when something is fully or partially submerged, an object in a fluid or liquid, there's an upward force coming from the liquid that is called upthrust. So upthrust is force which is acting upward. So this one is mass 1.3. So mass is a scalar quantity, you know, it's not a force. So we have to use another equation to convert it into a force. So the equation is W equals mg. I hope you're familiar with this equation. If not, quickly write it down. W equals mg. W means the weight, m means mass, and g means gravitational acceleration. Its value is 10. And the other thing is, when you use this equation, the mass has to be given in kilograms. Like all the physics equation, you have to use mass in kilogram. If they give in grams, you have to divide by 1000 to convert it into kilograms. Okay, so then they have given the mass is 1.3. So when you multiply it by 10, you are getting the answer as 13. So that is the weight. Now we know the weight. Okay, the weight of the swan is 13. Now they're asking not the weight, they're asking upthrust. For this one, you have to use the Archimedes Principle, children. Archimedes Principle is when an object is partially or completely submerged in a fluid, the upthrust acting on it is equal to the weight of the fluid displaced by the object. So now this principle they are telling that if something is now, think about a beaker. If it is completely filled with water and if you put something, some water is displayed. That displaced water weight is equal to the upthrust and that is equal to the weight of the object. So upthrust, weight of the object, and the displaced volume of weight of the volume, that both, all the three things are same. So because of that, you can take the upthrust as 13 newtons. So in this question, the answer is 13 newtons. The reason is according to the Archimedes principle. So first thing you're going to do is mass you want to convert to weight. After that, you have to use the Archimedes principle. So all these floating things, submerged fully, partially, those things they're asking about Archimedes principle. So you have to by heart this principle if you want quickly note the Archimedes principle and where we apply onto these upthrust questions. So the fourth one answer. Fourth question, answer 4. I will give you like 1 minute. If you want, quickly note down the equation and the Archimedes principle. Okay. So I will move on to this next question. One person is asking whether we can use Nm-2 for liquid pressure. Yes, whether we can use. Normally we are using Pascal, but Nm-2 also we could use for liquid pressure. Solid pressure we can't use. Sorry. Wait. For solid pressure we can use Pascal and newtons per square meter. For liquid pressure, as this equation is P equals H rho G, we are normally using Pascal. Yeah. Whether we can use Mn-2. Okay. I'll go for the next question then. Fifth one. The atmospheric pressure at the sea level is 1 into 10 to the power 5 Nm-2. So this time also they have given atmospheric pressure in newtons per square meter. So we could use it for both. Fine. The area of the tympanic membrane means within your ear you have the tympanic membrane. What is the force exerted by the atmospheric pressure? So for this one, you have to use the equation now. They are talking about atmospheric pressure, but they have given the area pressure and asking you about the force. That means you have to use the equation pressure equals force over area equation. So when you use the equation pressure equals force over area, they have given now the pressure. It's 1 into 10 to the power 5. The force they're asking you to find. And the area is 5 into 10 to the power minus 5. Okay. So now you have to use the equation and you have to substitute the values. So after you substitute the values with it, you have to make F subject. Now you can see 5 into 10 to the power minus 5 is the denominator. So you have to do the cross multiplication. You have to take this one here and multiply. So when you multiply that plus 5 to minus 5, they get cancelled out. So then the answer would be F equals 5 newtons. So your answer is the first one. Okay. So this for science also, this simple equation substitution is really important. So you have to practice that. So I hope you're okay with this one. We'll go for the next question. If you want to write down the equations, you're free to write down. And if you want to note down anything, you can note it down, children. Okay, we'll move on to the sixth question. Which height of the following barometer could be used to find the atmospheric pressure? So to measure atmospheric pressure, we have to use a barometer. We have two types of barometer, children, Mercury Barometer and Android barometer. The common using the talking one is Mercury Barometer. And in this setup, you can see the Mercury Barometer and this space here, that is a vacuum. Yeah, you can see a vacuum here. So if you can roughly sketch, or in your paper, you have the barometer. So here you have a vacuum. And from this length only, you're measuring the height of the pressure given by the atmosphere. The height of the mercury column gives you the pressure of the atmosphere. So they're asking which height could be used to find the atmospheric pressure. It should be QR. So the second answer we have to take. And think about when you climb up or when you go for nodelia, like some height, that more height from the sea level, in that case, the pressure decreases. So this height would decrease. So always in this mercury barometer, you are measuring the atmospheric pressure by considering the height of the liquid column. The reason is with it, we have a fact in the liquid pressure at the same level is same. Liquid pressure at the same level is same. So in here, you can see the pressure at here is equal to this one, because the pressure at the same level is same. So here pressure is equal to the atmospheric pressure. That's why we take it as this QR height. Is it okay about the liquid pressure? So the mercury column is given the atmospheric pressure. Answer is the second one, QR. So what you have to note down is pressure is measured by barometer. We got two types, mercury barometer and the aneroid barometer. The pressure is given by the height. And also you need to know when you go up in the altitude, or when the pressure decreases, this mercury column will falls down. And the top space between P and Q, it is filled with vacuum. Vacuum means no particle, nothing, just empty space. Okay. I will move on to the next question now. Okay. Seventh question. This is from the now up to the sixth question. I discussed the questions related to the pressure lesson, solid pressure, liquid pressure, and gas pressure, the atmospheric pressure. And also I can tell you that atmospheric pressure, they're asking the applications of atmospheric pressure, like in those rubber suckers, siphon method, when you drink straw using a straw, those things explain the applications of atmospheric pressure. You can note down or highlight that also, because I have seen in the papers, they're asking what are the applications of atmospheric pressure. Okay, but then now I will move on to the chemistry lesson, that chemical changes lesson. Sometimes it will be, as it is a long lesson, maybe now you have avoid that lesson, but there are some really interesting parts and which they are asking. So now you can note down the important things with this, so you can study at least them to cover up the thing. All right, now look at there. They have given information regarding a metal. So we don't know what is the metal is. They are telling it displaces copper from copper sulfate and it is extracted by electrolysis. So this question, it's basically focused on the activity series. So if you didn't study activity series, actually it's difficult to do this question. So you have to give attention on the activity series. So quickly you can note down the activity series which I have given there. The order is potassium, sodium, calcium, magnesium, aluminium. There's a reason to put carbon there, but you know carbon is not a metal, but I will tell the reason later. We have put carbon there, zinc, iron, tin, lead, and again we have put hydrogen there, copper, silver, gold, platinum. Okay, now in this activity series, the most reactive one is potassium. Potassium is the most reactive one, and in the school labs even we normally don't use potassium, we use sodium. Even sodium, because of its high reactivity, we stored sodium in paraffin-kerosene oil. In some question papers they're asking why sodium is stored in paraffin-kerosene, because it's highly reactive. If you just keep it open to the environment, it will react with oxygen and water vapor in the atmosphere. So we have to put that thing in kerosene or paraffin oil in order to prevent the reaction, because the top ones are called highly reactive metals up to aluminium. And then the middle part, zinc, iron, tin, lead, we call them as moderate reactive metals. They're like medium reactive. And the down ones are called native metals, or they are the unreactive ones. So, you know, gold ones and silver, platinum, those things, they are not much reactive. They're actually unreactive ones. That's why we place them down in the activity series. Okay, so I hope you can write down the activity series quickly, or in your textbook or your note. Just mention put there, the top ones are the highly reactive metals, middle ones are the moderate reactive metals, and the down ones are the least reactive metals. And also you have to keep it in your mind, these highly reactive metals, that means the top ones, they are extracted by electrolysis. So now as you have done grade 11 syllabus, you know what is electrolyze, electrolysis. Electrolysis means by sending electric current, you do a chemical change. So when you want to make sodium, you get sodium chloride. And when you send electricity through that, you can make sodium and chlorine separate. So in the chemical bonding lesson, you learn atoms to become stable, they form bonds. And for our users, we break the bonds and separate the elements. So that is called electrolysis. So if anyone want to know the meaning of electrolysis, that means breaking down of chemical compounds by using electricity. So these top metals, as they are highly reactive, they always form compounds. We separate them by using the method electrolysis. So in your activity series, you can just put a curl bracket there up to aluminium and mention they are extracted by electrolysis. Now I will tell you the reason to put carbon there. This zinc, iron, tin, lead metals, they are extracted by heating with carbon. Reduction with carbon, they are extracted. So that is a reason why we put carbon in between the top one and the middle one. So you can mention the reason. I have given it in the presentation, like extract burning with carbon. So middle ones are extracted by burning with carbon because carbon is more reactive than them. Down ones, you can just clean it or just burning in air. You can easily separate the down one, the bottom ones, because they are least reactive metals. Okay, one question. All right. Then now the thing what I use for this question is they are telling it displaces copper from copper sulfate. So if something displays copper from copper sulfate, that means it should be something above copper. Now, normally I'm taking the example like now, if your school principal is coming to your class and asking your teacher to go somewhere, she has to go. And if the teacher asks you to go out of the class, you have to go. Like the hierarchy ones, the top ones can displace the down ones. So in the activity series also, the highly reactive ones can displace the low reactive ones. Like potassium can ask copper to go somewhere by taking the other radical of copper. So like that way, the highly reactive ones can displace the low reactive ones from their compounds. So you can mention that as a fact. In this activity series, highly reactive metals can displace the low reactive metals from their compounds. So they are telling copper is displaced from copper sulfate. That means that element obviously above copper. Something above copper should be there. That means somewhere here above copper. Okay. All right. So you can avoid the answer silver. AG answer you can avoid because it is down copper, so it can't be silver. So now it can be either zinc, potassium, or lead. Next point they are telling it is extracted by electrolysis. Now if you know the fact I told you, it obviously should be something top element. So you can avoid zinc and lead. Answer is potassium. So if you know the theories, finding answer is really important, but for this one, you have to study the activity series. By using a song or something, you have to study this activity series. And about this extraction methods, the top ones are electrolysis, middle ones are burning with carbon, down ones native elements, you can extract them easily. Okay, and the important thing is highly reactive metals can displace the low reactive metals from their compounds. Okay, so I hope you understood that question also. Yes. Then I will move on to my next question. Question 8. Okay, now this one, they are asking the final products of the reaction of hematite with carbon monoxide gas in the temperature range 1000 to 1900 Celsius. Okay, but then now they're talking about iron extraction. So when you see this question, the thing should come to your mind is iron extraction. So this iron extraction is done in a blast furnace. So here you can see in the diagram, the image that is called blast furnace. It is the place where we extract iron. For that, we use 3 raw materials. Now you can quickly write this down, children. That is what I expect you to get something from this seminar, like increase your knowledge, like improve your knowledge. You learn something, now, this is not something new. So I'm not going to teach from the beginning because you already have done these, but just to refresh your memory and to support your this upcoming paper. All right. So then in this one, the instrument is blast furnace. Sometimes they ask in that also. And from the top, you're adding the 3 raw materials. Hematite, that is the iron O, hematite. It is Fe2O3. Coke, that means carbon. Limestone, calcium carbonate, CaCO3. So they are the 3 raw materials added from the top. Hematite, carbon, calcium carbonate, that means limestone. Okay, now after that, from the bottom, they send hot air. Heated air is sending like 1000 to 1900. So when this hot air coming from the bottom, from the top, we add in the raw materials. And inside the blast furnace, there are series of chemical reactions takes place. You have to by heart the equations. It's easy if you study from the symbols. Like first, carbon react with oxygen to form carbon dioxide. That's the first reaction. You can write it down. C plus O2, CO2. Carbon reacts with oxygen to form carbon dioxide. And after that, this carbon dioxide further reacts with carbon, O, to make carbon monoxide. CO means carbon monoxide. If anyone can't remember, just note it down. So the first one, carbon plus oxygen, carbon dioxide. Then carbon dioxide plus carbon, carbon monoxide. After that, this carbon monoxide reacts with hematite. And then what it do? Remove oxygen and form Fe plus CO2. So now we extracted iron. In this reaction, you can mention this carbon monoxide is acting as the reducing agent. Reducing agent means now from the iron, they removed oxygen. So it's reduces. Oxygen gaining is called oxidation. Removing is called reduction. In grade 10 syllabus, you don't have that, but in grade 11, you learned about oxidation and reduction. So then losing oxygen is called reduction. So this carbon monoxide, it removes oxygen from iron. So you can tell it is the reducing agent. Sometimes they can ask you what's the purpose of carbon monoxide. It acts as the reducing agent. So you can have iron and carbon dioxide there. Okay, so they're asking what is the final product when hematite react with carbon monoxide. So the final product is iron plus carbon dioxide. So the answer is first one. Okay. So answer is 1. Other ones they have given you to confuse, like oxygen is not there at all, but it's just using to heat up. Okay. And about limestone thing, I will explain you in another question. We have that. I will explain there. So these are the very important things. Quickly highlight or note down the facts. The instrument is blast furnace. The 3 raw materials, coke, hematite, limestone. Hematite is the iron O, Fe2O3. And these are 3 reactions, very, very important. Carbon plus oxygen, carbon dioxide. Carbon dioxide plus carbon, carbon monoxide. Carbon monoxide reacting with hematite, Fe2O3 to form Fe plus CO2. Okay, children, I will move on to the next question then. Question 9. Okay. This is, I think, the first part of this lesson. They have given you 3 types of equations and asking you what is this type. So we have 4 types of equations, like 4 types of chemical reactions: combination reaction, decomposition, single displacement, and double displacement reaction. So combination means 2 things combine and forming something new is called combination. Now in here they have given B reaction, iron plus sulfur, iron sulfide, or carbon plus oxygen, carbon dioxide, hydrogen plus oxygen, water. Something, if 2 things combine and a new thing is formed, we call it as a combination reaction. So you can note it on all the when 2 things combine, forming new things. So that is called combination. You can note it down as you like, for which makes you easy for you to study. Okay, and then the second one is decomposition. Decomposition reactions, it's easy to identify because one reactant break into 2 or more. In decomposition, only one reaction. So that is the only type you have only one reaction. So I think the easiest one to identify is decomposition. One reactant break to produce two or more. So in this first reaction, you can see in A, limestone or calcium carbonate decomposed to calcium oxide and carbon dioxide. So that is a decomposition reaction. So you can select answer 2 or 3, and the B is combination. So you have to go for the C1. Okay, in this presentation, I have included another 3 equations with it, which is given in your textbook. That 3 also, I feel it's important because they're asking questions about these 3 most of the time. Like potassium permanganate decomposition. This reaction is important for you're learning it for oxygen production, and something easily we can do in the lab also when you heat potassium permanganate and you can obtain oxygen gas. This equation you have to study, and this potassium permanganate is purple color crystals. They're asking that also, the color of potassium permanganate, it's purple. And when you decompose this or when you heat this, you can obtain oxygen gas. So give your maximum effort to study these equations. It will really support you. And the second one is limestone decomposition, like calcium carbonate decompose into calcium oxide and carbon dioxide. So in that also we need it for ion extraction thing, and in the papers they're asking, so you can study this. That is also a decomposition reaction. The next one is hydrogen peroxide. For this reaction, there's another important thing for catalysts. In the rate of reaction lesson, for catalysts, they are talking about this hydrogen peroxide equation, which used to clean wounds, and it's a colorless solution. Write down these points. You will understand why I'm telling this are important when you're practicing papers, because sometimes they are giving some chemicals and asking you to separate them, and in that they are giving it's a colorless solution which produce oxygen, or it's a purple color substance which produce oxygen. So with the colors and the appearance, you should be able to identify them. So potassium permanganate is a purple color solid which you have in the lab. Hydrogen peroxide is a colorless liquid, and when you decompose that, you can have water and oxygen. This reaction also you use it for oxygen production in the lab. All right. So then these are about decomposition reactions. So with the C1, C reaction, now you know with the answers, it's coming to the single displacement. This displacement reactions, you have to explain with the activity series. So that's why again I use the activity series there. The theory is, again, highly reactive metals can displace the low reactive metals from their compound. So when you put zinc into copper sulfate, zinc can displace copper and get sulfate. So they are forming zinc sulfate plus copper. So this is called single displacement reaction. Okay. And think if you put copper to zinc sulfate, so copper is down and zinc is up. So copper can't displace zinc. So like you can't ask your teachers to go out of the class. Like you can't ask, so because that highly reactive ones only can displace the low reactive ones. That's the nature. So here also, if you put copper into zinc sulfate, there will be no reaction. But if you add zinc into copper sulfate, it can displace. So as one compound is displacing, we call it, one element is displacing, we call it as single displacement reaction. So the answer would be, first one is decomposition, second one is combination, third one is single displacement. So the ninth one answer is 2. You have to select second answer there. So that is the answer. You can mark down your answers, but my main task is to get the theory. All right. So here we use the activity series. Highly reactive ones will displace the low reactive ones. Okay. And the fourth type of reaction is for the double displacement reaction. In that, the both, like now, as an example, if you take something like zinc sulfate plus like sodium chloride, so they will exchange both the polyatomic ion part. Like now it will form sodium sulfate plus zinc chloride, something like that. In the double displacement reaction, they exchange both the polyatomic ions, like So there is nothing highly reactive or low reactive, they exchange. So we call it as double displacement reaction. So if someone worried why it is Na2SO4 not NaSO4, that is about the valency. I think in your previous session you learned about writing formulas and valency. So sulfate is with the SO4 2 minus, its valency is 2. So when you exchange the valencies, sodium get Na2SO4. But in this zinc sulfate, there is no 2. The reason is zinc valency 2. So that is something additional, but you need it. Okay, so we have done 9 questions. We will move on to the next one. Okay, 10th question. They're asking you to select the response which gives acid, base, and salts. So to find acid, base, and salts, I think this pH scale also helping for you. From 0 to 14, we have the numbers. 0 to 6. Now, quickly write it down. I'm not again and again telling. So now you should have the need to build up your theory or your short notes. So it will support period 4 to study. Okay. So then from 0 to 6, you have acids. In question 7. Okay, but after I do this one, I will go to that one and tell you. Zinc, so 0 to 6 is acidic, 7 is neutral, 8 to 14 is alkali or bases. So which one is given acids? So acids, but they normally is easily you can remember they contain hydrogen because they gives out hydrogen ions. Like HCl, sulfuric, nitric, those things are the main acids you have in the lab. So you can quickly write it down. The symbols are important because now as you can see in this question also they are given from the symbols. So you must by heart the symbols. Hydrochloric acid means HCl, nitric acid means HNO3, sulfuric acid means H2SO4. So then the answers 1, 2, or 4 you can select because in the third one it's sodium hydroxide. For bases, you can take metal oxides, metal hydroxides, or carbonates. They are hydrogen carbonates. They are considering as bases. So you can take the second or fourth answer like. And the last one they're asking about salts. So salts means with they normally chlorides, sulfates, nitrates. They are considering as salts. So now the name of the salts comes with the acid. Now think that acid is hydrochloric. The salt would be a chloride like sodium chloride, calcium chloride, magnesium chloride. They all are salts. And if the acid reacting to form salt is sulfuric, that would be sulfate like sodium sulfate, potassium sulfate, calcium sulfate, like that way a salt. And if the acid is nitric acid, the salt would be a nitrate. So that's how you have to get the name. So you can see hydrochloric acid is an acid. Say CaOH twice means calcium hydroxide. It would be a base. Copper sulfate is a salt. So the 10th one answer is 4th one. All right. 4th one is the answer. And I want to tell you something in third lesson. They're asking that in the chemistry lesson, third lesson, you learn metal oxides are bases, non-metal oxides are acidic, and something amphoteric, aluminium oxide. That is also important place for you to remember. So metal oxides, now like when you tell sodium oxide, potassium oxide, you don't feel they are base, but metal oxides are bases. At the same time, non-metal oxides, now normally if you tell acids, they are like hydrochloric, sulfuric, nitric. But if you take like carbon dioxide and nitrogen dioxide, sulfur dioxide, you don't feel they're acidic. But still, non-metal oxides are acidic. So, okay, so non-metal oxides are acidic. So that's the important thing because something not catching your mind. Like normally when you heard the word acids, you know it's hydrochloric, nitric, sulfuric. But non-metal oxides are acidic, like carbon dioxide, silicon dioxide, sulfur dioxide, those things also acidic. Okay, some people ask question. I will quickly go to that. In 7th question, why it can't be zinc? One is asking why it can't be zinc in the 7th question. Okay. Okay, but who asked that So why it can't be zinc in the 7th question? Because they are telling it's extracted by electrolysis with it. So electrolysis to extract, it should be the highly reactive ones, not the middle ones. Zinc is at the middle. Middle means it's a moderate reactive one. So it is extracted by heating with carbon. Zinc O is there. It's heating with carbon. To extract by electrolysis, definitely it should be someone above copper, like, above carbon. Potassium, sodium, calcium, magnesium, aluminium, one of that should be to extract by electrolysis. Zinc ion, they belong to moderate reactive. They are extracted by heating with carbon, reduction with carbon. So I hope that person would understand. And next one, okay. Definition for single displacement. Okay, one person is asking the definition for single displacement reaction. Single displacement means with the highly reactive metals. If someone wants, you can write it down. Single displacement means highly reactive metal can displace the low reactive metal from its compound. I don't think they would ask you the meanings, but for your knowledge, you will need that. The highly reactive metals can displace the low reactive metals from their compounds. Okay. We'll go for the 11th question. That is also somewhat related to the activity series. So I think I'm telling again and again for you to study this activity series. All right. So then within this one, they're telling you want to find the reactivity of metals, and they're asking you to form it in the descending order. That means the highest one to the least one. Okay. So then in this table, you can see X is reacting with everything. With dilute acid, with steam and cold water, it reacts with everything, means obviously it should be the highly reactive one. So X is the highly reactive metal. And you can see why it's not reacting with anything like something silver, gold. So that is the least reactive one. So Y should be the least reactive. Then the other two only you have to compare. W reacts with, but W does not react with cold water, not with steam, but react with hydrochloric, something like moderate reactive ones. And Z reacts with steam and hydrochloric acid. So then the next one, the most reactive next one should be Z, because it's react with steam also. Something like magnesium maybe. Magnesium does not react with cold water, but with steam and hot water it reacts. So the order should be X, W, Y, Z. So the 11th one answer should be the second one. I hope you got this. So the second one is the answer. You have to think about how they react. So if they react with everything, that is the most reactive one. If they does not react with anything at all, it should be the least reactive one. And the other ones you have to compare. So in this one, that's important thing for you to remember is about magnesium thing. So because it's not reacting with cold water, but it reacts with hot water and steam. And another thing, I will tell you some additional thing, but you can write it down with it. If a metal reacts with water, they produce the hydroxide and hydrogen gas. As example, sodium with water, sodium hydroxide and hydrogen gas. And this sodium reaction also in the papers they're asking, when you put a piece of sodium into water, what are the observations? Like I think you all have done this practical in the school, or maybe you have seen the videos. They floats in water. Sodium, it floats in water and the metal disappears. You can hearing that fizzing sound, shoo sound would be there, and a gas bubble is given out. So these observations you can get when sodium reacts with water, and the products if they ask the hydroxide and hydrogen gas. Likewise, if any metal reacts with water, if it's reacting, they produce the hydroxide and hydrogen gas. And if it's react with hot water also same, hydroxide and hydrogen gas. If it's react with steam, they make oxygen and metal oxide and hydrogen gas. Like magnesium, it react with steam to make magnesium oxide and hydrogen gas. Okay, so group 1 metals, they react with acids, but we don't put normally because of this vigorous reaction, it will explode violently. Group 1 metals, they are highly reactive. Okay, one person asked 10th question answer. 10th question answer is with the fourth one. Hydrochloric acid, calcium hydroxide, and copper sulfate. That is the answer for the 10th one, fourth answer. Okay, I will move on to the next question soon. Okay, 12th one. They have given you some reactions and asking which one, in which of the following instance does a chemical change occur? In which one of the following does a chemical change occur? So with it, first you need to know, Ravin is asking whether magnesium is reacting with cold water. We are telling very little or like no reaction. They're telling like no reaction or very slowly reacting, but hot water and steam, magnesium is reacting, but with cold water actually like no reaction, or some books and things they are telling like very slow reaction or no reaction. Okay, so then okay, so in this one they're asking which one is a chemical change. So if chemical change happens, something new should be formed. So they're telling physical ones, only the arrangement of particles are changing, only the physical state is changing, but in the chemical changes, a new substance is formed. Think about you burn a paper. So can you reverse it back to the paper again? No, never. So that means it's a chemical change. Like if you burst a cracker or something, that by collecting all those stuff, you can't make that again. If you react sodium with water, you can never have that sodium again. So like that way things, if a new substance is formed, we called it as a chemical change. So here I have taken some examples from your textbook. Burning of firewood, heating limestone, heating potassium permanganate, the two reactions I told you is important, and rusting of iron. So they are chemical changes. And physical changes means with only the state changes, like condensation of water vapor, like the water droplets, and crushing of stones, maybe melting of wax, vaporization of water. That means nothing that you have ice, you heat that, it turns into liquid water. And you further heat that, it turns into vapor. But if you cool, you can get the liquid again. And if you cool the liquid, you can get the solid again. That means it's not chemically changed. It's just the state changes. So that is called a physical change. So they're asking in which instance does a chemical change occur? The answer should be burning in firewood. In the mothballs, but they like that, they directly changing to a thing that if you heat that thing, it will change it into a vapor. And if you collect that thing or cool it, you can have the solid back. So that's why it's not the mothballs. Firewood, if you burn that thing, you can't reverse it again. Mothballs, if you can collect that thing and if you cool it, you can get the vapor back. So I hope one person asked that, he would get the answer. So here the answer should be 12th one. Its second answer, burning firewood. Okay, I will move on to the next one. Okay, this equation I told you it's important to study if you can, like potassium permanganate, KMnO4. This Mn, it's not capital N, it's not nitrogen. This is manganese with this, so it should be capital N and simple N. So it's potassium permanganate decomposed into potassium manganate plus manganese dioxide plus oxygen. Okay, now they are given, this is the balance symbol equation for the decomposition of potassium permanganate. Why they are telling it's balance? They have put 2 in front. Can you see? When you balance equations, you put numbers only in the front, not in the middle, not in back. You just put the numbers in front. Our purpose is to balance reactants and the product atoms in both the sides to have equal number of atoms. So you can see in your product side, you have 2 potassium. So to balance that in front, they have put 2 potassium. So now manganese becomes 2. So you can see 2 manganese in this. And oxygen, there should be in the product side, there is 4. 2 and 2 means it should be 8. So in the reactant side, when you put 2 in front, 2 times 4, 8. So the other thing you have to keep in your mind is when you put any number in front, it affects for the whole compound, not only for the first element, it affects for the whole compound. Now, when you put 2 in front of potassium manganate, it becomes 2 potassium, 2 manganese, oxygen, 2 times 4, it becomes 8. I hope you understood this. In the second one, if it is K2MnO4, it means it has 2 potassium, 1 magnesium, 4 oxygen. So keep it in your mind, if you put any number in front, it's just not for that first element, it's for the whole compound. So it will be 2 potassium, 2 manganese, and 8 oxygen atoms. All right. So that's not the thing they're asking. They're asking, find the number of potassium permanganate moles needed to produce 3 moles of oxygen. So this is like molar ratio, but they like we are taking the ratio between these compounds. They're asking, they want to produce 3 moles of oxygen. And they're asking, find the number of potassium permanganate. So this one, we don't have an equation. We have to take that. Yes. In maths, you are taking, if you go to the shop, if you have this much, then you buy this much. That method you have to follow for this question also. So in this one, you can see, if you break 2 potassium permanganate, you can produce 1 oxygen. So this KMnO4 to oxygen ratio is 2 to 1. The ratio is 2 to 1. That's the main thing you have to identify. Why I'm telling 1? In front of oxygen, there are no values. No values means it has 1. You know, in maths, you won't put 1x, 1b, like that way you're not using, you just put x. So when it is x, you know it has only one thing. So here also in the equation, there is no front number, means it has 1. So then the ratio between potassium permanganate to oxygen is 2 to 1. That means if you break 2 moles of potassium permanganate, you can have 1 mole of oxygen. Okay, so they're asking, if you want to get 6 moles of oxygen, how much should be potassium? So you can put x, you can do the cross multiplication. Like when you take that thing, so x would be 6 moles. Or with your general knowledge, you can find if 2 gives 1, to get 3, you need 6. Any method, but that is the thing, molar ratio between potassium permanganate to oxygen. You have to get the molar ratio. Some are calling stoichiometry also. You can compare. That's it. So answer is the 6th one. 4th answer, answer 6. Is it okay? I hope one boy send me the answer also, I think. Yes. Okay. So I saw there were questions from this one. Just you have to get the ratio. There was one other question. I will explain you furthermore in that. All right. So we'll move on to the next question. Fourteenth one. Look at this one. This is also similar. So calcium carbonate reacts with HCl to make calcium chloride plus carbon dioxide plus water. So in this reaction also, I told you, to do these calculations, these reactions must be balanced. If it is not balanced, you can't do this one. So definitely it has to be balanced. So then to balance that, you have 2 chlorines there. So in front of HCl, you put 2. So now it has 2 hydrogens, 2 chlorines. Now both the sides it's balanced. And if you compare, I will tell you how to compare that thing. 1 calcium, 1 calcium. Check that. Then 1 carbon, 1 carbon. Here we have 3 oxygen, but that side also you have 3 oxygen. But hydrogen and chlorine is the problem. So you put 2 in front. So it makes 2H, 2Cl. Now it's balanced. Okay. Now they're asking you to find the mass of calcium chloride made from 50 grams of calcium carbonate. Now they're asking you to find the mass of calcium chloride from 50 grams of calcium carbonate. So in this one, you have to start from where they have given data. Now they're talking about calcium carbonate and asking you about calcium chloride. So you have to start the question with calcium carbonate. First, you can find its MR, or relative molecular mass, molar mass. You have to find the MR of calcium carbonate. I hope the early session you learned how to find that. So I have showed you here calcium carbonate. These atomic masses with it, they are given in the question. Atomic mass means number of protons and neutrons, the mass number or the atomic mass, they are given in the question. Here they have given calcium 40, carbon 12 in the paper also, they are giving that. Just you have to add that ones and multiply and you have to get the answer. It's like now carbon 40, calcium 40, carbon 12, oxygen is 16. There are 3 oxygens, so it's 3 into 16. When you add this, it will be 100. So, and if you find the moles per gram, the molar mass unit is now the difference between molar mass and relative molecular mass. The same method you are using to find, but relative molecular mass has no unit. Molar mass has a unit, moles per gram. So it has a unit. And then calcium chloride, also you have to find its relative molecular mass. Calcium 40, chlorine there are 2, like 35.5 into 2. So it will be 111. So now you can see, if you check the equation, 1 calcium chloride form 1 calcium carbonate form 1 calcium chloride. I'm telling 1 because at 1 mole in front there are no numbers. So 1 calcium carbonate produce 1 mole of calcium chloride. That means if now 1 mole means molar mass. If 100 grams of calcium carbonate react, they produce 111 calcium chloride. Then if 50 grams react, how much? Again, I told you that cross multiplication method. So then if 100 produce 111, then 50 grams, how much? X. Then you have to do the cross multiplication. When you do the cross multiplication, you take X there. So X equal 111 into 50 divided by 100. So then you can simplify that. When you divide 111 by 2, you would get the answer as 55.5, third answer. Okay, so I hope you understand that you have to get the molar ratio method. Okay. First, you have to find the calcium carbonate mass. Your mass means with a molar mass of 1 mole. And then you're finding the calcium chloride. If that thing reacts this much, you have to go for that method, cross multiplication method. If you have any doubt or if you want to explain it again, you can ask from me. I will do it. The main thing, you have to get the idea, 1 mole react with 1 mole. That idea. If it is 1 to 2, that molar ratio is the most important thing in this calculation part. So the answer is 55.5, third answer. We'll move to the 15th question today. In this one, you have, they're asking which method can be used to collect carbon dioxide gas. So I have included the equation. Quickly note it down, or you can highlight in your one. How to make carbon dioxide. We put limestone again for that conical flask. This diagram I have included in the presentation is important. Maybe for the theory paper or essay paper, they are giving this diagram and ask you to label parts. When they'll ask you to label parts, mostly they're asking about this thistle funnel and the beehive shelf. They're asking what is that instrument? It's beehive shelf, delivery tube, gas jar, trough. These parts you have to label. So this diagram is important for all the 3 gases. We use similar diagrams. So you have to learn how to label this. Okay, now when these 2 react, they produce carbon dioxide. Now, when you take carbon dioxide with it, now you can see with the diagram, you can collect it over water. But it's slightly in the thistle funnel, from the thistle funnel only, they are adding the acid. In the bottom of the flask, they have the calcium carbonate, limestone, and from the thistle funnel, they add acid. Because when you use a thistle funnel, it's like it has a long spout and it has a long neck, so you can add directly to the calcium carbonate without going here and there. So they add use thistle funnel to add the acid. Okay, so the thing is, carbon dioxide can be collected over water. So the C method is fine. You have to select whether it's A or B. To select that, you have to think about the density of carbon dioxide. For this one, you're comparing with nitrogen actually, because our atmosphere mainly contains nitrogen. It's 78%. Mass of nitrogen is 28. That's not something you need to study, but just keep it in your mind. AR of nitrogen is 14, so it's 28. If someone's MR is greater than 28, if someone's mass is greater than 28, we are telling it's denser. Less than 28, we are telling it's less denser. So carbon dioxide, if you count its MR, you don't need, just keep it in your mind, it's a denser one. Like it would be 12 plus 16 into 2. So the answer you are getting is 44. That means it's obviously greater than 28. So it's a more denser one. So if it is more denser, it's always try to go down. If something less denser, they would go up. You know, hydrogen balloons, they moves up because it's less denser. So this carbon dioxide gas is more denser. So it's come down. So the answer should be A and C only. 15th answer, third one. because it's more denser. You can write the reason why carbon dioxide go down. It's more denser. And C method is it's not much soluble. It's a little bit soluble. It's not totally insoluble. You know that like soda and soft drinks you make by dissolving carbon dioxide in water, but it has to be cooled. Like if the normal temperature, it's difficult to dissolve. At cold temperatures, they can dissolve. You learned in that solubility lesson. Okay, I will move on to the next ones. I just added the other gas preparations also. Hydrogen gas, we react zinc with hydrochloric acid. Now in hydrogen gas, you can see whether it's a lighter gas, so it's moved up. So it's collected by the downward displacement because the jar is downward, the gas is going up. Both the methods are fine for hydrogen. Hydrogen, you have to use this method because hydrogen is less denser, it moves up. Carbon dioxide, it's more denser, it comes down. And oxygen gas preparation in the lab, you have these equations. From these equations also, if you got your textbook or your writing book, just highlight this. Potassium permanganate, hydrogen peroxide ones are really important to study. So in this one, you heat potassium permanganate, you can see these purple color crystals, and you collected oxygen gas over water. That also it's slightly soluble, not totally insoluble. You can observe the gas bubbles moving up and the water level comes down. The diagram labeling is important. I'll move on to the 16th question. All right. This is again about the iron extraction blast furnace. So I included this diagram earlier. So I think you noted down everything, but in that I didn't tell you what's the reason to adding limestone. So we use that coke to react with the oxygen to make carbon dioxide, carbon monoxide, and we use iron ore, hematite. Why we add limestone? Now without limestone, we extracted iron also, so we don't need limestone. But we need limestone to remove the impurities. To remove impurities, we need limestone. So what are the impurities in this? Now when you take iron ore with it, it's not pure iron. You know, ore means it's containing oxygen and some impurities like sand. Like sand means SiO2, silica, or maybe alumina, Al2O3. So those things are mixed with this iron because iron is a moderate reactive element. It reacts with other elements and compounds. So it's as a mixture compound. Some mixture is there for the iron ore. So the impurities are calcium oxide. Sorry, impurities are silicon dioxide and alumina, Al2O3. To remove that, we use limestone. So my question was why limestone was added to the blast furnace? To remove the impurities in the iron ore. So the 16th question answer is third one, to remove the impurities in the iron ore. How to do that is, first the limestone has to decompose into calcium oxide plus carbon dioxide. Then that calcium oxide reacts with SiO2 and Al2O3. They make slag. That is calcium silicate or calcium aluminate. At least calcium silicate you could study, CaSiO3. Don't tell when they ask what's the reason to add in limestone. To remove slag. Not to remove slag, to remove sand as slag. So some people say that when they ask why they add limestone to remove slag, no, they added it to remove the impurities as slag. Slag means calcium silicate, and here you can see in this diagram, you have like two drains. Iron goes down and this slag floats in iron as two layers. Iron is down, slag is floating. So by using two drains, you can separate that. Okay, so I hope you understood. The 16th one answer is third one. Okay, we'll move on to the next one. 17th question. They're asking, according to the information in the table, which metals that are most likely to represent X, Y, and Z. So I have added some pictures for you to get the observations properly. If something burns with yellow flame, you can see nicely the yellow flame, it's sodium. That's why they're using for street lamps to get that yellow color light. So that's sodium. And then if it is burns with bright white flame, that should be magnesium. You can see how bright it's burning. And if it's burning with, yes, with the slag they are using for, and one person is asking whether you can use slag for different purposes. Yes, they are using for that as a tar-like for road carpeting, to do road carpets and all, they use this slag. They have many other uses of slag. Yes, true. Okay, so burning magnesium is a white color substance and potassium gives the purple color flame. Then they're asking easily burns with yellow flame, then it should be sodium. So either 1 or 4th answer. And burns with bright white flame, it should be magnesium. So answer should be 4th one. And when I talk about this, Z does not burn because of oxide layer. Always this oxide layer is formed by aluminium. So the answer should be 17th one, answer 4. It should be aluminium. Sodium, magnesium, and aluminium. Fourth answer. Calcium can be burned with a calcium burning, that means calcium ion. Calcium ion gives crimson red, as I can remember. Strontium. No, it's like brick red, as I can remember. Calcium. Strontium is given the crimson red. As I can remember, it burns with brick red color. Calcium ion. If you want, I'll check and tell you surely. I think it's brick red color, the calcium one. But they're not teaching that calcium in your syllabus, so they're not asking that, but for your knowledge, that's fine. I think it's brick red color. Okay, we'll move on to the 18th question. All right, this is about the rate of reaction. Now I did like as much as I can for the chemical changes lesson. So basically you have to study the activity series about the 4 types of reactions: combination, decomposition, double displacement. That part you need to know. And these gas preparations, they are really common questions in your papers. So give attention on those areas. All right, Vidya. Now when we move on to the rate of reaction question, for rate of reaction, this rate of reaction means the amount of change occurred in a unit time. What is the change occurred in the unit time? So rate of reaction, you can measure it in 2 ways. One is amount of reactants used up divided by time taken, or the amount of products forming divided by time taken. That means sometimes you can measure the time, or you can measure the products or reactants. That is how you are going to find the rate of reaction. So you know some reactions are really, really slow, like rusting and maybe ripening of fruits. Those reactions take time, slow reactions. But normally the reactions we do in the lab, they are fast reactions. So we can find the rate. These are the factors. You can write them down, children, or highlight. The factors affecting for the rate of reaction are surface area, temperature, concentration, and the presence of catalyst. Sorry. So the surface area, temperature, concentration, catalyst, and pressure. When you talk about pressure, it's only affecting for gases. It's only affecting for gases, not for the solids and liquids. All right. So then surface area, when it is powder, they have large surface area, so more rate of reaction because there will be more successful collisions. In the theory paper, if you're writing why surface area increase the rate of reaction, you have to mention it allowed to do more collisions. And temperature, when you increase temperature, particles gain more kinetic energy. So they move faster. There will be more collisions again. So the rate of reaction increases. Concentration means like you increase the amount of particles. Now think that you use concentrated acid. That means it has more acid particles. So the acid particles are closer to each other. So there will be more collisions again. So the rate of reaction is high. About this catalyst, I will explain later. Look at the question now. Sulfur dissolves with hydrochloric acid. Which of these situations does the rate of reaction reach its maximum level? That means which one will give the most rate of reaction? So, you know, than the dilute acid, concentrated acids are reactive. The difference between dilute and concentrated means with a dilute means it has more water. If you don't know the meaning, you can mention dilute means it has more water. Concentrated means it has less water and more acid particles. So there will be more rate of reaction. And if you compare zinc powder and sheet, when it is powder, they have more surface area around each. They're not talking about the size of the particle. Now think that a box-like thing, if you break it into small powder, the surface area of the whole thing is high. So then powder, it has more surface area, more rate of reaction. So the answer is third one, concentrated acid and zinc powder. 18th one answer, third answer. Okay, with the 16th question, one is asking the answer for the 16th one. 16th one answer, to remove the impurities. The reason to adding limestone is to remove the impurities. Impurities with a sand or alumina, they are the impurity. They are removing as slag. Okay, so the 16th one answer is third one. 17th, I told you the answer, fourth one. And the 18th one answer, third answer, concentrated acid and zinc powder. We'll go to the 19th one. Okay, in this one, they're asking what is a suitable method to increase the rate of reaction between a solid and a liquid. So when you have a solid, but then normally, if you want to increase a reaction of a solid, you can use the powder form. That's the easiest thing. Think about when your mothers cook, they put salt crystals and powder. So when powder, they can directly put into the curry, so it will dissolve. Or something you eat, you can just spread that thing because it dissolves quickly. It reacts faster, the powder. So that is the easiest one. So the 19th one answer, you can take the second answer. But if you cool that, rate of reaction would be decreases, because when you cool, they have less kinetic energy. When you heat only, they have more kinetic energy. And if you increase the concentration, as I told you earlier, there will be more particles, more collisions. So if it's decreased, rate of reaction would decrease. No mean of using equal masses, it has no connection. All right, I want to tell you about catalysts. Catalyst means they are the substances that increase the rate of reaction without being chemically consumed. So catalysts, they increase the rate of reaction, but they do not waste during the chemical reaction. So I have a it's good example for catalyst. I think it's like teachers. Now when teachers teach you, your knowledge increases, but nothing happened to our knowledge. When we give you my, now today, when I give you my knowledge is not reducing, but your knowledge would increase. So this catalyst also somewhat like that. He increased the rate of reaction, but no chemical change. Nothing happened to the catalyst. Now think if you use 5 grams of catalyst, at the end of the reaction, even you have 5 grams. So there's nothing happening, but he's just speed up the thing. So that is called catalyst. And the other thing is catalyst, they can't use it for every reaction. There are some catalysts for different reactions. So I think you can remember for hydrogen peroxide thing I told you, it used manganese dioxide catalyst. So that is manganese dioxide only for that reaction. Now I can teach you science, but I can't teach the other subjects maybe. So like I can catalyze only these science lessons. So like that way, these catalysts, they also specific. Therefore, specific reaction. There are some examples. If you have space in your mind, you can study some of them. They are asking. One of the favorite one is like margarine production. They use nickel catalyst. For ammonia production, they use iron catalyst. For sulfuric acid production, they use vanadium pentoxide. Sometimes they may be big words. Nitric acid production, they use platinum. So these catalysts. Now for margarine production, you can't use iron catalyst. It's only nickel. So like they are specific, they increase the rate of reaction without being used up. You learned in first lesson enzymes, they are biological catalysts. For biological things, they are also acting as catalysts. So I hope you understood about this catalyst. All right. So that is additional thing, but in the papers, they're asking about catalyst. All right. Shall I move on to the 20th one? This is also from the rate of reaction. Which conical flask have the highest and the least rates? So these questions are easy. You could easily score the marks. So when you compare the temperature, the high temperature one would give more rate. So the temperature is 25, 50, 50, and the other one, it's 25. So 50 temperature one would give the more rate of reaction, and the concentrated acid and the powder. So C would give the highest rate of reaction, and the least would be given by low temperature, dilute acids, and the pieces. So A would give the least reaction, C would give the highest reaction. 20th one answer is C. C is the answer. All right. So there are also just the 4 factors. I think by now your note is completed for the rate of reaction. The factors are temperature, surface area, concentration, pressure is only for gases, and the catalyst. So catalyst, I told you clearly, it's specific only for some reactions, but they speed up, nothing happens. Temperature, when you increase, obviously rate of reaction high because they gain more kinetic energy. When you compare ribbon, pieces, powder has the greatest surface area, more rate, and the other one is concentrated acid, because when the concentration increases, there will be more particles, more rate of reaction. Okay, children, so by the time we did up to the 20th question, so quickly go so far and tell me if you have anything to ask to the chat, you can send me. Till the 20th question, I will give you 2-3 minutes. Tell me if there's anything you want to ask. 15th question answer, maybe you have breakouts. Uh, 15th question, Pute. It's A and C only. Third answer. 15th one. Yeah, it's A and C only. Third answer. Yes, someone is asking with the molar mass of the element equal to the atomic number. Atomic number? So this molar mass of the element equal to the atomic, not the atomic number, Pute. Molar mass means mass number. Atomic number means number of protons. You have a confusion in that. Listen now, atomic number means number of protons in the atom. Mass number means protons and neutrons. So molar mass of an element is equal to the mass number, not the atomic number. I think for the person who asked that question, it will be all right. All right. Some person missed 12, 13, 14 answers. Okay. Shall I repeat the answers again? Some people have missed maybe connection issues. I will repeat the answers. Can you check your answers again? First one answer 2. I will repeat all. You can just check your answers. First one 2. Second one 3. Third one 4. Fourth one 4. 5 1. 6 2. 7 2. 8 1. 9 2. 10 4. 11 2. 12 2. 13 4. 14 3. 15 3. 16 3. 17 4. 18 3. 19 2. and 23. Third answer. So if I think now you can manage that thing. 14th question. Okay, someone is asking for the 14th question. All right, that is the calculation part with it. Someone is asking about this one. In this calculation part, normally they are giving you the equation. All right, and it should be balanced. If not, you have to balance, but I think for your syllabus, they are giving the balanced equation. And the reason to balance is with that only you can go for a ratio. All right, now this equation is already balanced. So this means 1 mole of calcium carbonate reacts with 2 moles of HCl to give 1 mole of calcium carbonate. Now think that someone give about this calcium chloride and HCl question. Then you have to take the ratio as 1 to 2, not as 1 to 1. In this question, they ask about calcium carbonate and calcium chloride. That's why we took it as 1 to 1, because the ratio is 1 to 1. If they ask now 100 grams of calcium carbonate make how much HCl, it should be twice of that. HCl mass twice, not 100 into 200, not 200. If you have to find the MR of HCl, that thing times 2 they have to make. So always this front number is for the ratio. So in this question, they are asking how much calcium chloride can be made from 50 grams of calcium carbonate. In that, first you have to find the MR of calcium carbonate, or molar mass, relative molecular mass. So it would be 100 if I do the calculations, and you want to find the molar mass of calcium chloride as well. It would be 111. So 1 to 1 ratio. So 100 will produce 111 grams of calcium chloride. Then 50 how much? You have to do the cross multiplication or half of that simply. So 100 half is 50, then 111 half, 55.5. The ratio thing is the concept in this. Molar ratio, or we call it as stoichiometry. If they ask for calcium carbonate and HCl, the ratio is 1 to 2. So chlorine is 35.5 and that thing plus, now if I do something like calcium carbonate to HCl, the ratio is 1 to 2. So if 100 reacts, they would produce HCl is 36.5. So that thing times 2 you have to take. That should be the answer for HCl. All right. So like that way you have to take the ratio. I think he understood. All right. Only that much questions. Shall I move on to the next 20? All right, then we will continue. All right. Now we have done the rate of reaction lesson for the physics one. The SI units of energy, power, and the potential difference respectively are. Like these were questions, but they're asking respectively. That means accordingly, the order you have to follow. So energy means ability to do work. So energy, you know, it's does not have mass and take space. So like you have energy examples like light energy, heat energy, or we call it as thermal energy, kinetic energy, potential energy. So we have different types of energies and they all are measured by joules. Standard unit of measuring energy is joule. So you can select answer 1 or 2. Then power we measured by watts. It's capital W, so it's watt, and the potential difference is volt. So these were questions also they're asking, but sometimes you get confused with these letters and all. So the answer is first one, 21. 21 answer is first one, yes. Joules, power is W, potential difference is V. So it's a first one, okay. We'll move on to the next one. All right. Then the 22nd question, the velocity of a carom disc. 1 second. The velocity of a carom disc is mass 10 grams is 4 meters per second. So velocity, you know, it's a vector quantity. All right, sorry. Okay, so then velocity is vector quantity, it's meters per second, 4 meters per second, and the mass is 10 grams. So mass definition also, it was there in your first term lessons, the amount of matter in an object. So then the kinetic energy you have to calculate. Kinetic energy means with the energy found in moving objects. The moving objects, they have kinetic energy. We have an equation to find kinetic energy. It's half mv squared. Kinetic energy is half mv squared. Then we have to substitute the values for these equations. And the other main thing I told you, when you use physics equations, the mass definitely should be given in kilograms. If they give in grams, you have to convert that into kilograms. So it will be half mv squared. So then you have to substitute the values, half, then mass would be 10 grams. You have to divide by 1000 because you have to convert grams into kilograms. And the velocity, you have to get the square root of velocity. So it's 4 into 4. So then you have to simplify the equation. 0 you can cancel out. This 2 you can simplify. 4 times 2 is 8. And 8 divided by 100 means it would be 0.08 joules. So the answer would be second one. So basically in this part you should know kinetic energy means the energy found in moving object. This equation you have to by heart, half mv squared. M means mass. Always simple M we use for mass. In V we have a little doubt because for velocity also we use V, and for voltage also we use V. But from the questions you know that from the equation know the idea you should have which one is that. And when you study you can have some summary of the equations. Then I think it's easy for you to study because in physics directly they ask in the equations and you have to substitute the values. So the answer is second one, 0.08. I'll move on to the next question. 23. What is the, which one is the following is the energy transformation in a bicycle dynamo? So bicycle dynamo, you have a little thing, and the grade 11 also you have about the bicycle dynamo. It's working with electromagnetic induction. That means in the dynamo, when a magnet is rotating inside, a current is generating. So you can just have idea on dynamo, like it's working with electromagnetic induction. So in that, this wheel, its bicycle wheel is connected to the bicycle tire. So when the person rides the bicycle, this wheel is rotating. So the magnet rotates. When the magnet rotates, it's automatically producing a current inside. So mechanical energy is converted into electrical energy. That is the energy transformation. Mechanical energy means with it can be either kinetic or potential. So here use the kinetic energy and it is converted into electrical energy. So that is the energy conversion. And if you're telling about dynamo, this dynamo is used to produce electricity, and they're producing alternating current, AC current. That also you can note it down. Someone want to ask something? Okay. All right. I'll move on to the next question. 23, then 24. Okay. A child of mass 40 kilograms, walked along a staircase of a building for 6 meters. Now, this is a physics lesson part of it. So now you met one equation for kinetic. We'll go for the next equations. The time taken for the entire motion is 2 minutes. What is the rate of doing work? Now, work done, we have an equation. Work done equals force into distance, or magnitude of the force you have to multiply by distance. That is called work done. So you can calculate the work done when you multiply force and the distance. Now you will wonder, in this question there is no force. Okay, so then they have given the mass of the child. So this mass, there's a method to convert into weight. I told you in the very first question, 102 question. In that I told you, you can use the equation W equals mg. By using the W equals mg, you can find what is the force given by that mass. So W means with a weight. That means it is a force given by the person due to this gravity. So you could use the equation W equals mg, and you can convert this mass 40 kilograms. When you multiply by 10, you could get the answer of weight. So you have a force there. When you multiply 40 into 10, it's 400 Newton is the weight of the person. After that, you can use the work done equation. Work done equals force into distance. So then this is 40. Moment is not equal to work done with it, but it's something like a work done. That means moment equal, one person is asking whether moment and work done is same, like the equation is same, but the units are different. Now moment is the turning effect of force. So when you multiply force and the distance, you are getting the moment. It's measured by Newton meters. But work done, you measured by joules. So work done is a type of energy, like that's a difference, but the same equation, units are different. And it's not an energy, like it's something we do, but we need energy for that as well. So that's why they take the force and the work done for moment, and for power, for work done also force into distance, but the unit is joule. That's a difference. So you can't say that that is equal, but the equations are same. Units are different. And then, so it's 40 into 10 means it's 400. Newtons would be the weight. Then you can use the work done equation. So it's 400, and they have given the distance is 9 meters. So you can have the work done for 3,600 joules. Now they're not asking the work done, they're asking the rate of doing work. So rate of doing work means they're asking about power. So you need to know the work done in a unit time or rate of doing work is equal to power. So that you can write it down, or you can highlight, or you can do anything. Just have a note on that. Rate of doing work is called power. So power equals work done over time taken. So now you found the work done. It's 3,600, and the time taken is, they have given 2 minutes. When you use 2 minutes, we can't use minutes, but there we have to convert it into, you have to use seconds. So then 2 minutes, you have to convert it into seconds. For that, this 3,600, you have to divide by now. The equation is power equals work done over time taken. So then 3,600, you have to divide by 2. Not just 2, you have to convert it into seconds, so into 60. So when you simplify 6 times 1, it's 60. When you divide by 2, the answer would be 30. So the answer is first one, 30 watt. So I hope now in this question you met 3 equations. W equals mg, work done equals force into distance, power equals work done over time taken, and the unit of power is watt. You can take it as joules per second as well, but the standard unit is watt, capital W. Okay, one person is asking the answer for 23. Answer is third one, put there, mechanical energy into electrical energy. In 24, answer is first one, 30 watt. Okay, so the 25th one, okay, now this is for this current electricity lesson. Now they have moved on to the current electricity lesson. Yes, in this lesson, these resistors. So these are resistors. For resistor symbol, we have 2 symbols given. One is this box, and the other one is this line thing. One of this you can use for the resistor symbol. And before that, you need to know what is resistance. So resistance, I included that. 1 second. All right. Okay, so resistance means for the barrier to the flowing of current. If you want to note down, you can write it down. Resistance is the barrier to the flow of current. So barrier means when the current is flowing in a conductor, from the conductor itself, there will be some disturbance like. So that is called resistance, and the unit is ohm, standard unit is ohm. Now you will think, so why we need resistors? Resistors are used to control the current. So if you have resistor, you can now think that you have seen those huge circuits. They have different small instruments, like there will be different circuits, like their small appliances. They need different amount of current. Maybe one working with 10 amperes, other one working with 5 amperes, other one working with 3 amperes. Now think that the person who wants 3 amperes, if you give 10 amperes, that will get burnt. So you have to control the current. You have to reduce the current. So in front of that appliance, you put a small resistor. So the purpose of resistor is to control the current, to lower the current, right, for the protection of the appliance. All right. So then these resistors, there are two ways of connecting the resistors. One is series method, other one is parallel method. If they are connecting in a long line, we call it one after the other, we call it as the series method. And like this one, it's connecting as parallel method. So this is called the parallel method. And if it is in the series manner, it's really easy. You just have to add the values. Now think that if you have like three, if you have three resistors like connecting like this, and the value is 2 ohm, 3 ohm, and 5 ohm, something like this. So if you want to find the total resistance, we have a word equivalent resistance. You can just add these three. So 2 and 3, it's 5. 5 and 5, it's 10. So its equivalent resistance is 10 ohm. That's it. But if it is parallel, we have to go for that 1 over R method, that reciprocal method, we have to move. Okay, I will tell you what is that. So when you have now in this question, they're asking you to find the current flowing. So you know in this physics equations, the current, the important equation is V equals IR that we get from the Ohm's law. You definitely there will be a question from that. So it's V equals IR. In that V means voltage, I means current, and R means resistance. Voltage is measured by volts, I measured by amperes, and R measured by ohms. So this is the equation. You want to find current. Okay, they have given the voltage, but resistors, now there are two resistance values and they are arranged in parallel manner. Now what you're going to do is you have to find its equivalent resistance. Okay, so this is the method you're going to follow. You're doing 1 over R equals 1 over R1 plus 1 over R2, like all the things we have to take it as a fraction, like 1 over 2 plus 1 over, this is only 1. So you can write at the 1 over 1, oh, just 1 is fine. And then now the other part is maths, fraction simplification. So you can take this as the common and it's 1 and here 2, it will be 3. That is maths fraction addition. And then now this is 1 over R, we need R. So you have to get the reciprocal, you have to take it upside down. So then R would be 2 over 3. The R would be 2 over 3 ohm. This is the equivalent resistance. So I hope you understood. If they give 2 or 3 resistors, you have to take the like fraction you have to mention, and then you have to simplify the fraction addition, and then you have to take the reciprocal of that. Okay. Am I breaking? Oh, you can hear me well. Okay. All right. So then, all right. So the equivalent resistance is 2 over 3 ohm. Okay. Thank you, Sinesh. Then we have to use the equation V equals IR. Okay. We had to use the equation V equals IR. Children, just give me 1 second. Okay. All right. So then when you use V equals IR, now you have the total resistance. Then you can use V equals IR equation. Then voltage they have given it is 1.5, or you can use it as a fraction 2 over 3. Then I you want to find, R is 2 over 3. And then you have to make the I subject. You can write I equals this 3, you have to take it to the other side, 1.5 into 3 divided by 2. So when you simplify, you could get the answer as 9 over 4. Or else this 3 over 5, 1 over 3, you can take it as 3 divided by 2. So then again you have to do 3 divided by 2. So when you multiply, it will be 9 over 4. That means third answer. Like 1.5 means with a 3 divided by 2, you can use one of that and get the answer as 9.4. So somehow in this question, I want you to emphasize that how to find the resistors of the equivalent resistance of the parallel circuit. And then you have to use the equation V equals IR. That is very important for the electrical calculations. All right. So I will move on to the next one, 26th question. This one, which is the correct diagram to measure the current and voltage? Okay, so you need to know what are the instruments used to measure the current and voltage. To measure current with we use ammeter. If you want to measure a very small current, you can use either galvanometer or milliammeter. But to measure the current, you have to use ammeter. And the voltage you are measuring by voltmeter. And there are different methods to connect that thing. Current, you are to measure the current, you are connecting the ammeter in the series manner. That means in any place of this circuit, you can connect if you want to measure the total current. So the second one is also okay. Third one is also okay. Fourth one is also for the ammeter. So you can write it down. The instrument used to measure the current is ammeter. The symbol is that letter A. And it's connecting in the series manner. It has to be connected in the series manner. But if you want to find the voltage, you have to use a voltmeter. Voltmeter means when you are measuring the potential difference. Voltage means potential difference. So if you are measuring a difference, you have to connect it to the two sides. Now, if you're taking like, if you have a bulb, if you want to measure the resistance of a bulb, you have to connect it like this to the two sides. You want to get the difference. So we call it as parallel method. So ammeter, you have to connect it in the series manner. Voltmeter, you have to connect it in the parallel manner. But the positive negative charge terminals, you have to check. You have to fix it properly. That is a method. So the answer is fourth one. Ammeter series, voltmeter parallel. Fourth one. Those are the things you need to mention. Instrument and the method they are connecting. All right, I will move on to the 27th question. All right, which is the false statement regarding the electrical conductivity? So then the for the resistance, as I told you earlier, those who didn't mention that, resistance is the barrier to the flowing of current, and there are three factors affecting for resistance: cross-section area, length, and the material composition. Note down them. The factors affecting for resistance: cross-section area, length, and the material composition. Okay, so then I will check those questions, but after going to this one, sometimes they can give this in the question, that means a diagram form as well. They can give you like two equal lengths one and the different cross sections. So you need to know what happened to the resistance according to their these three factors. So when you have more cross-section area, now think about when you travel in the road. If the road is broader, there's less chance of traffic light. So then when the cross-section area of the metal is greater, so there will be less barrier. So there will be less resistance. So you have to mention when the cross-section area is increased, resistance decreases. So when there is more cross-section area, resistance is low. And when the length is high, resistance is high. So that's how it affecting. And the material composition is affecting. That means if you compare copper and nichrome, copper has less resistance. That's why normally for wiring purposes in the houses, we use copper. Nichrome has a greater resistance. It's using for that electric heaters and kettles we use that coil thing. That because it has high resistance, so it will conduct electricity less, so it heats up more. So then material composition also depends. So these are the three factors affecting cross-section area, length, and the material composition. And then they're asking the false statement: the resistance is inversely proportional to the cross-section. I think these two words also you're familiar. Directly proportional means if one thing increases, other one also increases parallelly. We call it as directly proportional. Inversely proportional means if one increases, other one decreases, we call it as inversely proportional. So resistance is inversely proportional to cross-section area. That means if the cross-section area increases, resistance decreases. Okay. Resistance directly proportional to the length. Resistance increases, length also, when length increasing, resistance also increases. Okay, that is also correct. Resistance of the conductor depends on the material it's made with. Yes, okay. Fourth one, they are telling temperature of the conductor has no effect on the conductivity. Normally, Pute, when the temperature increases, I told you the particles gain more kinetic energy. So then they move here and there. Again, it will reduces the current. So it has an effect. But we are not learning that much. But temperature also has an effect on the electrical conductivity. So the full statement would be fourth answer, because they are telling temperature has no effect on the conductivity. So it has an effect on the conductivity. All right, so the 27th answer is fourth one. But the three main factors affecting for the cross-section resistor is cross-section area, length, and the material composition. Okay, and we'll go to the next one. It's 28. Again, they're asking about units. Potential difference, it's volts, and the current, it's amperes. Resistance, it's ohm. It's an easy question, so it's the answer is third one. Answer is third one. Okay. So in this, I want to remind you about the Ohm's law. Ohm's law is about resistance, and according to Ohm's law, they are telling, it's a good point. Now here they are telling when the temperature is constant. Why? If the temperature increases or decreases, these things going to change. That means you can conclude that temperature has an effect on them. All right. So if the temperature increases, as I told you, they gain more kinetic energy. So then they move faster. So it has an effect on resistance. So that's why they define this law as when the temperature constant, current of the conductor is directly proportional to the potential difference. Current directly proportional. If the current increases, voltage also increases. That is shown by this graph. Can you see the graph? You can roughly sketch that thing. So when the current increases, voltage also increases. They are directly proportional. That is said in the Ohm's law. You can study that one. But the important thing is equation of this lesson, Ohm's law, V equals IR. And resistance is measured by ohm meter. Like we have ammeter, voltmeter. To measure resistance, we have ohm meter. The law, if you want, you can note it down or you can highlight. The graph is also important. When the current increases, voltage increases. All right. Shall I move on to the next one then? Okay, 29th question. Okay, this is about the resistor color codes. So before that, I told you, so resistance is the barrier to the flowing of current. We have resistors in order to control the current or to reduce the current. So then we have three types of resistors: fixed value resistors, variable resistors, and light dependent resistors. So I have given you the symbols of these three. The first one is the symbol for resistors. You can use either symbol. And the second one is for the variable resistor. Like you have an arrow in them, that is for the variable resistor. So they have different types, and in the mostly papers, they're asking you about this resistor color code for the fixed value resistors. So if you just take a resistor in your hand, it's really a tiny, small thing, and you can see those colored bands in them. There are like 4 colored bands with it. And for these ones, they are giving the values for your exam even. For these values, you don't need to buy hard, they are giving. But there's a calculation method you need to know. All right, this is how you are going to do the calculations. Now you can see in this band they have given, it has the bands A, B, C. Now they have not given colors. Normally they are giving you the colors and asking you to find the values. That is one method. In this method, they have given you the value and asking you to find the colors. Okay, now we'll see how to find. The value of the resistance is 320 ohm. So it's 320 ohm. So you can see first number is 3. So that's a tens place value. You have to find that color. So you can see in the color chart, it's orange. So the first one should be orange. First value you just write with the color, it's 3. The second band they have given it's 2. So 2 means it should be red. So the second band should be red. For the first two readings, you just take it as normal numbers like tens place value and the ones place value. So it's red, orange and red. So the value is 32. Third band, you are taking as an index of 10th power. You have taken a value as 10 to the power. So then here the value, now think that if it is, one second. Okay. Okay. So then that is you have to take it as a 10 to the power. So if the value, now think that the band is red, you have to take it as 10 to the power 2. Now here they have value 0. So value 0 means if you take 10 to the power 1, that means 10. So it should be the value 1. So the answer should be fourth one. It's orange, red, and brown, because that last one is 0 means that should be 10. Now someone could think as it is 0, it should be black. But if 10 to the power 0 means the value is 1. I think that is your maths knowledge you have learned. 10 always the power 1 is power 0 is 1. So then this is 10 to the power 1. Then you will get 10 as the answer. So then only you will get the answer as 320. So the answer would be orange, red, and brown. So the answer is fourth one. So always remember the first two bands, you are taking the normal values. If it is now think that the first two bands, if they give brown and red, so then it should be 12, 1 and 2. If they give red and orange, it's 2 and 3, 23. So first two bands, you are taking just the values. For the third band only, you have to think little. You have to take it as a 10 to the power. Then you have to put the values. If it is 10 to the power 3, you have to put 3 zeros. If it is 10 to the power 2, you have to put 2 zeros, like that. From the fourth band, you are calculating the tolerance value. It's normally giving gold or silver like. So the tolerance value, they will give you 5% or 10%. So you have to find 5% of this value or maybe 10% of this value as the tolerance. So that is for the fourth band. Okay. So I hope you understood up to this 29th one. I will move on to the 30th one. If you have any doubt, you can ask from me. Okay. This is also for the resistors and how they connect. So as I told you earlier, the resistors can be connected in two methods, series method and the parallel method. So in this, all the three setups, you can see the two resistors are in parallel and the other one is in series. Okay, so then they're asking which circuit shows you the highest and the lowest equivalent resistance. Equivalent resistance means the total resistance, which one is the highest and which one is the least. So now the thing is, I will give you a small clue to keep it in your mind. If the resistors are parallel, the equivalent is a very low amount. Normally, they arrange resistors in the parallel manner in order to lower the resistance. So now, by just looking at this circuits, you can see now the C1, they have 10 and 15 parallel. So that means it should be a low value. So when they have parallel mannered one, they have a low resistance. That's just a clue. All right, now we'll find that. I hope now you have tried this one. So if you go for first one in the A1, now when you have these two, you can see this 15 ohm resistor. I'm talking about the A circuit, 15 ohm resistor and the other resistors, that two are series. 15 ohm and the other two resistors are series, but 5 ohm and 10 ohm resistors are parallel. So first we'll find the equivalent resistance of 5 ohm and 10 ohm one. So then you can do 1 over R equals 1 over 5 plus 1 over 10. So then you have the common denominator 10. Then it's 2 plus 1. So it will be 3 over 10. And when you take the reciprocal upside down, it will be R equals 10 over 3. Okay. For this value, when you divide, you can just divide and get, or else you will get something 3.3 like. And that for that value, this 15 you have to add. For that 10 divided by 3 means 3.33. So with that, you have to add 15 because then that too are series. To find the equivalent of series circuit, you just have to add. So then it will be 3.3 and 15. The answer would be like 18.3 ohms. Just rough. You can have that answer. And then you have to go for the second one. In that second one, you have 5 and 15 parallel. So you can take 1 over R equal 1 over 5 plus 1 over 15. Then again, you have to follow the same method. You have to take the 15 as the common denominator, 5 times 3, and it's 1. So it's 4 over 15. Then you can take the reciprocal, R equals 15 over 4. Okay, that also you can divide and get the decimal. You're getting it as 3.75, I think. And then for that, you have to add this 10. Sorry, because that two are series. So you will get the answer as 13.75 ohm. All right. So then we will go for the next circuit, third one. There you have 10 ohm and 15 ohm in the parallel manner. So it's 1 over R equals 1 over 10 plus 1 over 15. Again, you can get the common denominator. Sorry, it's not 15. Then you have to take it as 30 like for the common thing. So it will be 3 plus 2. So it's 5 over 30. If you take the reciprocal, 30 over 5, then it would be 6 ohm. 6 plus 5, it would be 11 ohm. So now you got the values of all the three resistors. And then you can see the highest one is A, right? It's 18.3. The highest one is A because that 15 is connected series with it. So obviously the value would increase. And the least one would be C. So the order A and C. The 30th one answer is second answer. Is it okay? By the time I hope you all are okay with this parallel method of finding resistors, equivalent resistors. So you have to take this 1 over R method. And finally, definitely remember that you have to take the reciprocal of that because we don't need 1 over R, we need R. What is resistance? So you have to take the reciprocal. After that, you can add the series thing. Then you can compare the values. Is it okay, children? You understood this 30th question? If you have any doubt, you can ask from me. All right. Then shall I move on to the next one? Okay. 31. Now, as you're okay with this, okay, someone asking me to explain it again. All right, but then now in this question also, in this question also, you have the same method. I think you could catch up with this, so it will be all right. Just check this one whether you can understand. Now in this question also, but you have two resistors in the series method, sorry, parallel method, and the other one is series. Now, if you want to find the resistance of the parallel one, you have to use this 1 over R method. So you can just write it down for parallel 1 over R method. Okay, so what is 1 over R method? You have to use 1 over R equal 1 over R1 plus 1 over R2, that method. So what are the two resistors you have parallel? Two 6 ohm resistors. Now you have to take 1 over 6 plus 1 over 6. Then again, the usual method with you have to take the common denominator 6. So it's 1 plus 1. So that is 1 over R. And then 1 over R equals 2 over 6. So do we need 1 over R? No, we not. We need R. Okay, just give me 1 second. There was a problem with my tab. Just give me 1 minute. Okay, sorry for the inconvenience. Okay. Okay, children, really sorry for the inconvenience. Okay, we'll continue. All right. Okay, we were at the 31 question. Okay, sorry for the inconvenience. Okay, all right. So then in this question, you can see the two resistors, they are arranged in the parallel manner, and this 3 ohm one is connected in the series method. So in this one, first you have to calculate the equivalent resistance for the two parallel resistors that you can take. I can see that. So it's 1 over R equal 1 over 6 plus 1 over 6. So you have to take the reciprocal of this common denominator of this one. So that would be 6, and you have to take 1 over 1. It would be equal to 2 over 6. So when you want to find R, it has to be the reciprocal 6 over 2. So then it would be 3 ohm as the answer for that two resistors which are in the parallel manner. And that 3 ohm and this series 3 ohm that you have to add to find the total resistance. So it would be 3 plus 3. It would be 6 ohm for this whole circuit. The equivalent resistance would be 6 ohm. I hope by now one girl asking to repeat that thing again. So I hope the method would be okay. If they are in the parallel manner, you have to take 1 over R1 plus 1 over R2, 1 over R method. The other part is normal fraction additions. You have to take the common denominator. At that thing, finally, you have to take the reciprocal. So it would be 6 ohm in this total resistance. They are asking what is the potential difference for 3 ohm. For this 3 ohm resistor, what is the potential difference? Now for the whole circuit with it, the resistance is 12 volts, the whole circuit. But now they will divide. Now you have to know something. When the resistors are arranged in series manner, the potential difference divide, but the current is same. So what we are going to do is, I'm going to use V equals IR for 3 ohm resistor and find its voltage. For 3 ohm resistor, the voltage they are given is 12, and I want to find the current. R is 3 ohm. So if I'm finding the current through the 3 ohm resistor, I would be 12 divided by 3. So I would be 4 amperes. Okay, simply you can do like this, like if it's 12 volts and this is 3 and that one also 3, it's 1 to 1. So it's 6 and 6. No, but they are not they are asking the potential difference through 3 ohm resistor. So for the whole circuit, it's 12 ohm. Then there's nothing to do in the calculation. They're asking what is the potential difference for 3 ohm resistance. So when they arrange in parallel or series manner, the voltage divides. That's the thing. So then you have to find what is the voltage given for the 3 ohm resistor. So then this side also 3 ohm, that side also 3 ohm. So someone can guess it like 6 ohm and 6 ohm. But if you are doing it with the calculations, you have to do this. So you have to use V equals IR to find the current through 3 ohm resistor. So that would be 4 amperes. Now for that resistor, I'm going to use V equals IR. That resistor means 3 ohm resistor. So V you want to find. I is 4 amperes, R is 3. Wait. Then again it's 12. Just 1 second. Yes. Yeah, it's 12. Okay. So then it's a 12 ohm resistor, because the thing is this one also, as it is arranged in parallel manner, if you get the equivalent resistance as 3 ohm, so then same voltage is passing for the 3 ohm. Yes, wait, there's a small doubt with that. It's 4 amperes. Yeah. So the current 12 divided by 3, it's 4 amperes. Yeah, the answer we are getting as 12 volts. Yes, I have a small doubt in that. Just mark it as 12 amperes. I will 12 volts. I will check and confirm you with that thing. We'll take it answer as the fourth one, 12 volts. We'll see if there's any change. I'll let you know. Yeah, the answer is fourth one, 12 volts. Yes, fourth answer. Okay, we'll move on to the next question. If there's any doubt with that question, I will send you with the second one answer with it. That's not the way I did. Okay, we'll see. All right, I'll move on to the next question. 32. Since I had a doubt with that thing, early question, maybe I confused with the connection issue. Okay, 1 second. The answer, when I practice, I got 6 volt. Wait, this 31 question, just keep with it. I will explain at the end. Okay, when I get okay with the other one, just keep that thing. Yes, I got the answer 6 volts earlier, but when I do this now, okay, we'll see with it. Just keep that question. We'll go on to the other one. Before we finish the full session, I will do that thing again. All right, we'll move on to the next one now. Before we finish today's session, I will do that. Okay, so then we have another half an hour only. So then we'll continue. Before we finish, definitely I will do that. Okay, which one is the haploid out of given? So I think this is also you learned in the first session, like Meiosis and Meiosis thing you learned, and this is also helping for our last lesson, inheritance lesson. Okay, now the thing is, haploid means half of the chromosomes, which they have. Half of the chromosome is called haploid. Full set of chromosome. Now, as a human, we got 46 chromosomes, and haploid means they have only 23 chromosomes. So when you take these 4 examples, we have neuron, sperm, zygote, and parenchyma. So in this, sperm is a gamete with it. So gamete means they have half of the chromosomes. Then only here, look at this diagram. Gametes are haploid and they fertilize to form the zygote. So then these two, they should have 23 and 23 to form 46. That's how we got the zygote. So zygote is diploid. All the other cells, they are diploid. So sperm is the haploid one. They get half of the chromosomes. So if you want to know the meaning of haploid, that means half set of chromosomes. Diploid means full set of chromosomes. So in our all the body cells, we have diploid 46 chromosome, and that chromosome number, it's depends on the species. As humans, we got 46 chromosomes. So the sperm got 23. For that, there are two cell divisions involving meiosis and mitosis. So meiosis means it's called the reduction division. You can see parent cell, they had 4 chromosomes, but now daughter cells, they have only 2 chromosomes. So meiosis means the chromosome number get halved. So that is called haploid, like producing 4 daughter cells, which half of the chromosomes. And for the mitosis, they have 2 daughter cells with the same number of chromosomes. All right. So the answer should be sperm with the haploid one. So the 32 answer is second one. Is it okay? Is there any question related to this? If you got, you can ask. Other ones are diploid. All right, I'll move to the next one. 33, the genes that transmit parental characters to the offsprings is located in. So the genes which transmit characteristics are in the chromosomes or DNA, and they are inside the nucleus. So the answer is for the 33 one, the answer is nucleus, fourth answer. In this one, there you can roughly get an idea on the cell, plant cell, and animal cell. That is not the third term lesson, but still, as the last lesson, inheritance is related to this. You need to know about especially nucleus. Nucleus has chromosomes. In the chromosomes, they're made with DNA. Each chromosome contains 2 strands of DNA, and a section of DNA is called gene. So genes are the smaller one, which is in the DNA. DNA makes the chromosomes, and they are found inside the nucleus. Okay. So the answer should be nucleus. This mitochondria is the powerhouse which produce energy. Vacuole maintain the water balance, giving the shape. Cytoplasm is the jelly-like medium which chemical reactions take in place. All right. So the answer for the 33 one should be fourth answer, nucleus. Okay, we'll move on to the next one. 34. Not a hereditary disease seen in man. So in this lesson, you're learning how these characteristics are passing from generation to generation, how the characteristics are passing. So when these characteristics pass, some disorders takes place. Now, you know, I told you in meiosis that chromosomes, they get sometimes overlap and they are passing. So when they pass, sometimes there will be defects. So these are called hereditary diseases. So they are reasoned by mutations. Mutations, the singular word is vikurti, but it's not always bad. Mutations are, we can't say that it's good or bad, because mutations only lead us for evolution. It only makes us change. So some mutations may be bad, but not all. All right. So this, they're asking not a hereditary disease. So when you take these diseases, hemophilia, we have, now I have categorized these 3 diseases like sexually transmitting diseases means they spread because of sexual contraction, or by sexual contact, these diseases are transmitting, like gonorrhea, syphilis, herpes, AIDS. So they are not inherited diseases. They are not genetically coming. They are just sexual contact. So then they are not related to this. So this AIDS, gonorrhea, syphilis, they are not hereditary diseases. But when you go for the other ones, we have another type, genetic disorders due to the sex-linked recessive genes. So I think you can remember, females, they have XX chromosomes, and the males, they got X and Y chromosomes. Females XX, males XY. So there are some genes on these sex chromosomes. So we have 46 chromosomes, 23 pairs. That pairs, we call it as homologous pair. And then from these 23 pairs, 1 pair is there to determine sex, whether it's male or female. For the females, they have XX chromosome. For the males, they have XY. In this X and chromosomes, they have some genes. Even though they determine sex, some other characteristics are determined. For that, they have these diseases, hemophilia and color blindness. This hemophilia gene, hemophilia, what they do is the people with hemophilia, their blood is not clotting. That means when there's a wound or something, their blood is not clotting. They don't have the factor needed for blood clotting. So that is called hemophilia. And color blindness means they can't identify the colors, mainly red and green color, they can't identify. So we call it as red-green color blindness. So they have a problem with that gene. So that is coming due to a recessive gene in the sex-linked chromosome. That means X chromosome. And there are another two diseases coming due to gene mutations, albinism and thalassemia. Albinism means with it, their melanin pigment is not there. That means the pigment which gives the color to the body, that is called melanin. It protects us from UV rays. So these people who are albino, they don't have this melanin color. Their hair is getting white color, and these eyelashes, eyebrows, they are getting white color because they don't have the melanin pigment. So that is called albinism. That is also a genetic disorder, but not in the sex-linked recessive gene, not is in the X chromosome. Thalassemia also a disease like that. It's a blood disease. Less oxygen production, less oxygen transportation in the body. All right, so they're asking which one is not a hereditary disease caused in the man. So that should be anemia. Anemia we are getting due to lack of iron and vitamin B. So anemia means with it's like lazy, lethargic, they're like sleepy because they have less hemoglobin, and they have like less oxygen transportation. So that is called anemia. So that is not heredity. It's up to you to take enough iron or vitamin B, so you won't be suffering from anemia. So that is not a hereditary disease. So 34 answer is first one. All the other three diseases are hereditary diseases. Hemophilia and color blindness are due to sex-linked recessive genes, and albinism, thalassemia due to gene mutations. Okay, you can quickly note down this. I will give you 1 minute. Okay, children. I'll move on to the next question then. '35. All right, so the 35th question. Every child born to a brown-eyed father and blue-eyed mother has brown eyes. In the color of eyes, so they're asking the dominant and recessive. Okay, now these are called genetic diagrams. So in them, there you have some words you need to know. In this lesson, there are like 6 words you need to know. One set is genotype and phenotype. One is genotype, other one is phenotype. Genotype means gene combination that normally we put for tall, capital T, simple T, those things are called genotype. And phenotype means the outer appearance is called phenotype. And the other 2 words are homozygous, heterozygous. You can write down these because these are the basic words for this genetic diagram thing you need to know. Genotype is the gene combination. Phenotype is the outer appearance. Homozygous means they have 2 similar alleles. That means if you have like, if you think about the, now this one we take brown eyes and blue eyes I will take. So when you take letters, one you take capital, the other one you take simple letters. Now for brown eyes, if you use capital B, for blue eyes, you have to use simple B. Now, when these brown eyes cross with blue eyes, if all the children are brown eyes, every child want to brown and blue eye father, brown eyes. So if all the child is getting brown eyes, we can just conclude that brown color is the dominant feature. Dominant feature means with it is expressed when heterozygous. Now we have two words, homozygous and heterozygous. Okay, I will take letter B for brown. So if I'm taking brown is the dominant feature, it can be capital B, or capital B, simple B. So that means brown can be in two ways, either capital B, or capital B, simple B. Because it is dominant. Now, when you have simple B even, still brown is expressed. That means if the blue color gene is there, but they expressed brown color. So brown color is the dominant feature, blue color is the hidden feature. So that is the difference between dominant and recessive. And then blue eyes can be simple B. So these are the genotypes you can get. Phenotype are the eye colors. So this is homozygous, and this down one is homozygous. This is called heterozygous. For your knowledge, you can mention homozygous means similar genes, heterozygous means different genes. So when they are telling brown eye father and blue eye mother, they got all brown eyes. You have to get that brown eye is the dominant feature. So 35, the answer is second answer. Brown eyes are the dominant feature, because otherwise, if the blue eye is the dominant feature, the children should have blue eye. So this is, they are telling all the children are brown eyes one. So it should be the dominant feature. So 35 answers to. My most important thing is to get these words: phenotype, genotype, homozygous, heterozygous, dominant, and recessive. Okay, so dominant means when it is heterozygous, the expressed feature is called dominant feature. Okay, children? If you want further explanation or if you have any doubt, ask from me. I'll go to the next question. 36. All right. This is also about genetic diagrams. Now, in a genetic experiment, a tall tree and a short tree was crossed. The result could be. Now, that is a problem. Now, when they tell tall tree, they have to tell whether it's homozygous or heterozygous. Because if you take tall is the dominant feature, they can be either homozygous or heterozygous. I have taken the, look at the screen with it. In the first one, I have taken homozygous tall. So if you take a we have another word for homozygous called pure breeding. Just mention that some questions they are telling pure breeding as well. So if a pure breeding or homozygous tall plant crossed with a short plant, in the F1 generation, the first generation, all would be tall if it is homozygous. If it is heterozygous, there will be ratio of 50-50. So you can see in the next one. In here, like you can see, if the mother or father is heterozygous, the result would be different. So in the question, they have to specify whether it's homozygous tall or heterozygous tall. For short, no problem. Short is the recessive feature. It definitely simple D, because recessive ones are always homozygous. You can write it down. Recessive ones are always homozygous. Dominant one could be either homozygous or heterozygous. All right. Okay. So then this result is unpredictable. We can't predict the results. So the 36th one answer is 4. Because it can be either homozygous or heterozygous. They have not tell that in the question. So the result is unpredictable. I'll give you some time. Just draw these genetic diagrams. It is important. And the other one, this box-like thing, that is called Punnett square. You can use either this crossing method or Punnett square. Sometimes in the theory paper, like in the paper 2, if they ask you to use Punnett square, they have to use this Punnett square, this one. Or else you can do this normal crossing. That is fine. You can draw other gametes as well and do the cross. But as the same results come in, I didn't give that. Like this way, you can do the cross. Monohybrid plants means with it, like they are considering only one feature, like only one characteristics. For the O-level syllabus, we are taking only the monohybrid cross. We have dihybrid crosses as well. Like monohybrid means one single pair of contrasting character at a time, tall, short. Or else we could consider tall yellow seeds, short blue seeds, green seeds, like that way. So if you are considering two features, it's a dihybrid one. If they're considering a single pair of contrasting character, we call it as a monohybrid cross. That's the difference. So for your O-level class, you have to do the monohybrid cross, considering only one pair, like tall, short, red flowers, white flowers, like that way. So I think you understood why the result is unpredictable. If it is tall, or if they're talking about the dominant feature, they must tell whether it's homozygous or heterozygous. Homozygous, another word, pure breeding. Recessive one, always homozygous. So I hope you got the thing. And the genotype, phenotype with it. So the genotype is capital T, simple T. Its phenotype is tall. If you got simple T, the phenotype is short. Okay, so I hope it's done. Okay, I'll move on to the next question. 37. Okay, what is the phenotype ratio obtained when two organisms what is the phenotype ratio we get when two organisms of genotype capital T, simple T were crossed? Okay, so now both the parents are capital T, simple T, capital T, simple T. Okay. All right. So then now when you see this thing, you know, these two are dominant. These both are heterozygous. Okay. Now when you do the cross, you will get the result like this. You can have the gametes. And when you do the cross, the F2 generation, you are getting capital T, capital T. That means that person is tall. And this one also tall. This one also tall. So there are 3 tall people and 1 short person. So this is a ratio. So they're asking the phenotype ratio. So phenotype ratio, you can write it's tall to short 3:1. This is the phenotype ratio. If they ask genotype ratio, you have to write down capital T to capital T, simple T, then simple T, simple T. This is the genotype ratio. So there are 1 capital T, simple T, and 2 and 1. So this is the genotype ratio. This down one is the genotype ratio, but in the question they're asking you what is the phenotype ratio, outer appearance. So 3 people tall, the other one is short. So the ratio is 3:1. Answer is third one. If they ask genotype ratio only, you have to take 1:2:1. Okay, so you can note them down. If you didn't draw the genetic diagram, 50% of each, we get 50% in each only child. One person asks, we get 50% in each only in the, I mean, they're asking whether girl or boy maybe. Yes, girl or boy, the ratio of getting is 50%, XX and XY. So if you do the cross, I hope finished writing that cross and this phenotype ratio and genotype ratio. So for the sex determination, whether it's male or female, you have for males, it's XY for the father, and for the mother, it's XX. And if you do the cross, XX would be gives a girl, and this one also would produce a girl with this XY, and the other one also XY. So there will be 2 females and 2 males. So the ratio is 1:1 or 50-50. That is sex determination to have girl or boy. The probability is 50-50, 1:1 ratio. So now I hope you're okay with the genetic diagrams. I told it from the simplest thing like genotype, phenotype, and you have to give attention. If it is dominant, you have to think whether it's homozygous or heterozygous. If it is recessive, there's nothing to think. It's definitely homozygous. Okay. (38) Both sons born to a particular parents are suffering from color blindness. So when you draw these genetic diagrams for color blindness and hemophilia, you have to do it by using XY chromosomes. And also these genes are found only in the X chromosomes. These genes are not in the Y chromosomes. You can write that down also. These genes are only in the X chromosomes, not in the Y one. Both sons born to a particular parents are suffering from color blindness. So color blindness, we use the letter C. So that is getting due to a recessive gene. So if you get the simple C, that recessive gene only, you will get the disease. Which of the following can be exactly said regarding this statement. Which one could be the exactly? Okay, so then if you take mother is suffering from color blindness, I will draw and show you one genetic diagram. So mother, you can, if you take parents, if you take parents, mother is XX and the father is XY. All right, so then you have to draw the genes. Like now, if they're telling mother is suffering from color blindness, so we put letter simple C for both. If mother is suffering from color blindness, simple C for both, and father is healthy, think father is healthy, so they have capital C in this. All right, so then gametes, if you're drawing, you have to draw them again, like you can draw the gametes. And if you're getting F1 generation, if this crosses with this, if that egg crosses with the sperm, you could produce X capital C and X simple C. So that will be a carrier female. We are telling it has the gene, but it's that girl or that female version does not contain the disease. And this one, the boy, it's with simple C and Y. This boy has the color blindness disease. And this one with this, the other girl, again, capital C and simple C. So that is also a carrier. They have the gene, but not the disease. And again, this one with this, you can take simple C and Y. So you can see there in this, if the mother is suffering from color blindness, all the boys definitely would have the color blindness disease. So they are telling both son of a particular parent suffering from color blindness. So if the mother is suffering from color blind, definitely the boys would get colorblind, because boys have the Y chromosome and mother is getting the X chromosome. So definitely all the boys would get colorblind. Girls, they have the gene, but not the disease. They are called carriers. So we have diseased people, carriers, and the healthy ones. If you want quickly draw, it will be a little bit confusing because capital C and simple C is like alike, but just draw this one. For hemophilia and colorblindness, both, you have to give the genetic diagrams like this by considering X and Y chromosomes. For female, you have to put XX. For male, you have to put XY. Okay, quickly draw this. Yeah, fourth answer also put if both mother and father suffering from color blindness, obviously they will get colorblind. Yeah, fourth answer can be taken. Yeah, it has two answers. Because definitely if they both have like Y chromosome has no effect. So if both get simple C, all the children would get not. Now here's telling both sons. That's why we could get answer 1. If they're telling all the children are colorblind, then both mother and father are suffering from color blindness. As they're specifically telling both sons are with disease, you can take the first answer. If they're telling all the children are colorblind, so both mother and father suffering from color blindness, you can take. All right, we'll quickly move on as we have less time. We'll go on to the 39. The scientists who discovered the characteristics that determine of a special particular character, that is Gregor Mendel, who he is the father of genetics, who studied about the inherited characteristics and how these characteristics are passing. And he used the garden pea plant for his experiments. And the reason to use garden pea plant is because it's growing faster. You can get as pure breeding plants, and they are naturally self-pollinating. You can do cross-pollination. So there are many beneficial effects in the garden pea plant. So he has used this one, Gregor Mendel. And he said that for these characteristics are determined by a particular factor. Later only we call that factor as gene. At his time, it was not, the word was not there, but he said that there's a particular factor which determine the characteristics. So he's called father of genetics, and the plant used by him was garden pea plant. Its scientific name is Pisum sativum. All right, we'll move on to the next one. 40th question, last question. Which is not a rare inherited character. So inherited characters means with the characteristics we get from generation to generation, and there are common inherited characteristics as well as rare inherited characteristics. Some common inherited characteristics I have showed here: the skin color, the complexion is a rare common one, and the curl or straight hair, free or fused earlobe, the earlobe whether it's free or fused, and the ability to roll the tongue. When you keep your hands like your thumb, the position of the thumb, it also a common one. And the dimple cheeks, or the normal cheeks and the dimple cheeks, we call it as a common inherited characteristics. And some rare inherited characteristics are syndactyl, or they have like fused fingers, that's called syndactyl. And polydactyl is called, they have more fingers. You have seen some people, they have like more than 5 fingers, 6 fingers. And albinism, albinism means they don't have the melanin pigment. I told you they're those brown color, black color areas, they're totally white color. They don't have the melanin pigment. It's a inherited disease. And brown or blue eyes, that is also a rare inherited characteristic. So they're asking which one is not a rare inherited characteristic. It should be ability to roll the tongue. So the 40th one answer is third one. All right, so then I discuss all the 40 questions. There's a problem with the resistor one. I will do it soon. Now it's for you to ask question. If the suffering mother, if it is suffering mother, that means it's a diseased one. Otherwise, they have to call it as a carrier mother. Carrier mother means they have capital C and simple C. So they have the disease, but they're not the they have the disease gene, but they are not diseased people. All right. I will tell the answers again from the 20th one. Okay, wait, I will repeat. I will give you the answers with it, okay? Check your answers again. I will quickly repeat the answers from 20th one. Okay, from 21st one, we had to start. All right, so 21st one answer is first one. 21 answer 1. Then 22 answer is second one, 0.08. 23 answer is third one, mechanical energy to electrical energy. 24 answer is 30 watt. We did the sum. 25 answer is 9/4, third answer. 26th one answer is fourth one. 27 answer is 4. 28 answer 3. 29 answer fourth one, orange, red and brown. 29 answer 4. 30th one answer second answer A and C. 31 answer that I have to get that thing. Okay, wait. I will tell that 31 quickly. 32 answer 2. 33 answer 4. 35 answer 1. 34 answer 1, anemia. 35 brown eyes are dominant. 35 answer 2. 36 result is unpredictable, answer 4. 37 the ratio is 3:1, third answer tall to short, answer is 3:1, third answer. 38 mother is suffering from color blindness, first answer, because both sons are born to be that. If all the children, you can take the fourth answer. Then 39 it's Gregor Mendel, father of genetic. And 40 it's syndactyl. Okay, but they quickly go to that the question we missed. All right, look at there. So in this, as we did earlier, first you have to find the equivalent resistance of the resistors which are parallel. So you can take 1 over R equals 1 over 6 plus 1 over 6. In this, you can get the common denominator 6 and it will be 2. So then you can take R equals 3 ohm. So the equivalent resistance of this parallel one also 3 ohm. After that, you use V equals IR to find the total current in this. When you use V equals IR, voltage is 12. I'm talking about the total current. That means the current passing through this setup, that is I, and R is, you have to take 6. Because this is 3 ohm, this is 3 ohm, the total one is 6. So the current would be 2 amperes. All right, that's the place I think I jumbled. All right, so then the current is 2 amperes. After that, for these 3 ohm resistors, in the question, they are asking what is the potential difference across 3 ohm resistor. For that only resistor, we have to use V equals IR again. So then voltage you want to find, I is 2 and the R is 3, it would be 6 watts. Okay, I think here I took the wrong one. Okay, children, so the answer should be second one, 6 ohms. All right, so then listen again. So these ones are parallel. One girl asked how to find that. So the parallel one, you have to use the 1 over R method, reciprocal method, and then you have to find the equivalent resistance for that too. It's 3 ohms. 3 ohm, 3 ohm, the total resistance is 6 ohms. When you use V equals IR, it should be 2 amperes. Then that is a current. After that, they're asking what is the voltage for 3 ohm resistor. It should be 2 times 3, 6 watts. Okay, I hope now that is fine. Okay, so we discussed all the 40 questions. I think with the time, I try to cover up this the whole theory part related to that. 40th one. Wait. Uh, 40th one answer is 3, right? Yes, 40th one answer is 3 with it. I said something else. It's 3. Ability to roll the tongue is not a rare character. Okay, so only that much questions. Sorry, Pute. It should be third answer. Yes, it's the ability to roll the tongue is not a rare character. It's a common inherited character. All right. All right. Thank you, Sanesh. All right. Others, do you have any doubts to ask? Anything you want to clear? So I hope you will get the maximum of this for your O levels. Have a short note from this and study. For the second part, I hope we will send you a video or something to cover up the essay and theory questions. 26th one for the answer is 4th answer. 26th one. To go back. (26) it's 4, 24 it's 1. Yeah, it's 30 watts. It's 1. Some questions. 33, the answer is 4th one. 24, answer is first one. Yes, 33, it's nucleus. 4th answer. So only that much questions. Okay, so I hope you got something today. Madam?
Yes, Sachini.
Okay.
I take this opportunity to thank Mrs. Sachini De Silva who conduct today's seminar. As well as I would like to thank all the teachers who participated today, and dear students, I also would like to thank you for participating in this seminar, and I wish you all the best for your O-levels, and we will send the part 2 of this seminar paper as a video, and there is another seminar also we will conduct for you. So I hope that all of you will participate for that. Thank you very much. Again, thank you very much, dear Sachini, teacher, for conducting the seminar today. Thank you very much.
Okay, thank you, madam, for giving this opportunity.
I'll end up the session.